Hello everyone, this is Vasishta from Aerobi section. Today I am going to explain about doubly linked list and implementation on Python. How to implement on Python. So before we go into the topic of a doubly linked list, first we have to know about node data. What is a node data? As we know that information is that the user's data in the next back or the address of the next and previous node in the list. So a node is a collection of data with a node is a basic unit of a data structure, such as it is used in linked list or a tree data structure. Node contains data and also may link to other nodes. Links between nodes are often implemented by pointers. So as we can see, we have back, info and next, where back is an before before data and next is the next data and info is an user's data. Node data count can be determined in doubly linked list as class node, where it is we have to define everything in class. In class node, for def init function of self comma data which is that self dot item is equal to data, where self next is equal to none, where self previous is equal to none. In as we can see in this list data, there are some examples called David, Josh and Leah and Mariam, where the address of David will be going to Joshua and also to the Leah and also to the Miriam, from Leah to Miriam, and from Miriam to Leah and also from Josh and to the David. So the data is transferring from one person to last person and it is again coming to the first person. The address of a last element or last data is given to the first data. So finding a list item, we no longer need to use previous location. We can get the predecessor of a node using its back member. So as we can see, inserting a single linked list data where David, Josh, Miriam and Robert, and we can insert a new node Leah in between it. Finding a list item. If you want to find a list item, we need to insert into doubly linked list. As we can see in this diagram, list data David, Josh, and Miriam, and Robert and Leah. Inserting into doubly linked list, where new node is greater than back, that is equal to location back, and the location back next is equal to new node. New node is greater than next is equal to location. Location greater than back is equal to new node. Find item list data item location found. Retrieve item, insert item and deleting item are all required as such. Write a general non-number function find item that takes item as a parameter and returns location and found. Insert item and deletion. Delete item need location and retrieve item needs found. In special case of inserting in the beginning, we need to replace step 3 with a list data is equal to node. With Alex, David and Robert, we need to insert Alex in the first data. So inserting into a doubly linked list, inserting element at the beginning can be determined with the Python programming of a def insert to empty list self comma data is data, and if self dot start node is none, new node is equal to node data. Self dot start node is equal to new data, else print the list is empty. And inserting element at the end, def insert to end self comma data, check if the list is empty. If self dot start node is none, new node is equal to node data. Self dot start node is equal to new node, return n is equal to self dot start node and iterate till the next reaches null, while n dot next is none not none, n is equal to n dot next. New node is equal to new data and n dot next is equal to new data. New node dot previous is equal to n. Deleting from a doubly linked list. We have to be careful while deleting an element from a end cases, where the David, as we can see, we have an example with the list data of David, Joshua and Miriam. We need to delete Joshua So we need to add a location of Joseph first of all with the address of David and Miriam. If we delete these addresses, then the Joshua will be automatically deleted. So deletion. Deleting element from the start. The most natural way to delete an element from a doubly linked list is deleting from the start of a list. In order to achieve this, we will assign the value of the start node to the next node and then assign the previous address of a start node to null. But before doing this, we need to check two things. First, we need to check if the list is empty, and then we have to verify if the list has only one node or not. If the list has only one element, then we can easily assign the start node is to null. The following code can be utilized to delete node from the start of a doubly linked list. So, deleting element from the start. So, this program helps us to delete an element from a start in doubly linked list. Def delete at start self. If self.start node is none, print the list is empty, no element to delete. Return. If we return the function, we need to give the if condition. For if self.start node dot next is none, self.start node is equal to none. Then we have to return the function so that self.start node is equal to self.start node dot next. Self.start previous is equal to none. So, and we have to see that deleting from end. We need to, if we want to delete from end, deleting the item from end gives us the def delete at end self. First, we need to check whether the list is empty. Then we have to give the function if. If we give if function self dot start underscore node is none, then we have to print the given def function, which is that linked list is empty, no element to delete, and then we have to return the function if self dot start node dot next is none, then self dot start node is equal to none. Then we have to return the function again, and then if we are giving an element with n is equal to self dot start underscore node, then we have to give condition. If we give while condition, we have to give while loop. If we give while loop, while n dot next is none, it's not none, then n is equal to n dot next. N dot previous dot next is equal to none. So, this is an Python programming regarding deleting from n. Next, transversing the linked list. The transversing the linked list depend on display the elements in doubly linked list while iterating through each element. Transversing and displaying each element in the list includes that def display self and the condition if is given, so that if self.start node is none, print the list is empty and then return the function. Then if we give another condition else, n is equal to else self.start node, and we are giving loop inside it while n is not none, print element is n item, n is equal to n dot next, print n. Then we get the transversing of an element. As we can see, I have taken this Python programming from the source of a Fav tutor. So there is a total programming regarding doubly linked list with a class node def init and a class doubly linked list with a def init function self.start node is equal to none. Def insert to empty if a self.start is none, and then def insert to end and a def delete at start and a def delete at end, def display where all the doubly linked lists is given, so that we get the printing of if we give the printing, we'll get an answer on regarding doubly linked list. So as we have to see from beginning, class node, first we have to define node. From that, the def init self data, self item is equal to data, self dot next is equal to none, self dot previous equal to none. Then class doubly linked list is given with this def init self dot start node is equal to none. Then def insert to empty list self comma data. If self dot start node is none, new node is equal to node data. Self dot start node is equal to new node, else print the list is empty. Insert element at end, def insert to end. If a self dot start node is none, new node is equal to node data. Self dot start node is equal to new node. So this is all regarding the doubly linked list and implementation in Python. Thank you.